let us remember that if we're given the acceleration as a function of time, we can find the velocity simply by deriving the acceleration. Sorry, we can find the velocity by integrating the acceleration. So if we're given the acceleration as a function of time, that function can be integrated from a time a to a time b, and that integration will give us a function that will give the velocity. If we derive the velocity, we'll get the acceleration. If we're given acceleration in terms of space, we can find the acceleration again from the velocity terms, or we know that space as a function of time can give us velocity. So in other words, if we have a function that is say we have a velocity and acceleration is in function of space, we can still have this type of derivative, so that at the end we can have our acceleration in terms of x, which is space, and still continue with having a velocity with an initial velocity and a final velocity. Okay, so I hope that's not confusing. One thing is having the acceleration in terms of space, and one thing is having the acceleration in terms of time. All right, and obviously if they're giving us the acceleration in terms of velocity, that means that if we derive the velocity with respect to time, that's going to give us the acceleration in terms of velocity, and we can obtain the space from velocity. So I hope this is not too confusing. Just the point here is that acceleration can be a function of time, but also can be a function of space. And that is because if you think about it, we're starting to think of in terms of a vector acceleration that can have components both in time and in space, right? So at one point, we talked about this already, at one point in time, a time 0 is going to have a location, and a time 1 is going to have a different location, and then that path could be found as a function of time or as a function of space. All right, so let's look at an example right here. So they are throwing a ball with an initial velocity of 10 meters per second. It's vertically, so we're given that this is our origin, and we only care about y, the vertical axis. And they're saying that they're doing that from an initial height of 20 meters. So they're asking us to determine the velocity and elevation at a time t. So in this particular case, we have acceleration as a function of t, and we have to find what is the velocity. So remember, if we're given an acceleration in terms of t, then the velocity divided t is equal to that function that we're given. So all we have to do really is to integrate the velocity, and this is the function t right here. So integrate our acceleration, and we're going to do this from an initial velocity to a final velocity, and from, this is with respect to t, and from a time 0 to a final time. So this right here is basically the velocity in terms in time, the velocity in terms of time minus an initial constant velocity. If this is 0, then that goes to 0. If it's not 0, like in this case, it's not 0, then we have to keep that constant. And this is equal to whatever the acceleration is given. What is the acceleration in this case? Is negative 9.81. So This is going to be negative 9.81, which is actually not a function of t, it's a constant. So really, if we were to do this the right way, it would be 3, 2, 1, go. 3, 2, 1, go. A being a constant, so A equals negative 9.81 meters per second squared. Therefore, what we have is a constant integrating t0 to t dt. So all this is equal to a t from t0 to t. Okay. And t0 would be time equals 0, or could be also a different time that we're interested in doing. I guess at this time we can just say that this is, this is 0. So this is equal to 0. So the velocity minus an initial velocity, because it's not 0, is equal to the acceleration evaluated at t final minus 0. Okay, so right now we can just say that our function is 9.8 t. Alright, so right here we have our velocity function. V as a function of t is equal to negative 9.8 t plus an initial velocity. This is a function that we have derived already, and here it is, we can use it again. So from now on, you can just use this function, which the general form is a as a function of time times t plus v0, or initial velocity. If it's 0, even better. All right, so that is just for the velocity. Now, if we integrate that, well, first of all, recognize that dv dt is equal to, or let's do this. If trying to go ahead and we're not done with this. We know that the velocity as a function of t is equal to negative 9.8 times time. So this is the variable time, 1 second, 2 seconds, etc., plus 10 meters per second. And this will definitely work out because this negative 9.8 has units of meters per second squared, and time is in seconds, so meters per second and meters per second. This will have units of meters per second. So this is correct. Okay? All right, so if we say that the velocity, okay, so let's do, this is one of the equations that we're going to need. And then we say that the y as a function of t, remember that we're in the y direction, dt is equal to v of t, but that really is 10 meters per second minus 9.8 meters per second squared times t. Okay, so we can integrate this and say the integral from y0 to y final, y of t, is equal to the integral of v function of time dt. Okay, and that means that y of t from y0 to y final is equal to 10 times t Well, the integral, really, let's do this. This is from v0 to, with respect to t, this is from t0 to a final t. Again, we have to integrate with respect to time again. So let's do this. From 0 to a time that we need to find, and the function is time 10 minus 9.8 t dt. All right, so if you recognize this, we have that y final minus y o initial is equal to the integral from 0 t of 10 dt minus integral 0 to t of 9.8 t dt. All right, this is equal to 10t from 0 to t minus 9.8 t squared divided by 2. This is basically 4.9 t squared from 0 to t. So y final minus y of O initial equals 10 times t minus 0 minus 4.9 t squared minus 0. Okay, so we're getting closer to the answer. So the y final is a function of t minus, or actually equal to 10t minus 4.9 t squared plus y initial. So y of t is equal to 10t minus 4.9 t squared plus the initial length, which is 20 meters positive. 20. Okay, so this is equation number 2. All right, so now we're ready to solve the questions here. So velocity and elevation above the ground at time t. So that is not very intuitive, that is not easy to understand, but what they're asking is, what is the velocity when it reaching the maximum height, right? So the velocity and elevation above the ground at time t. What they're trying to say is that from this equation, we're gonna say when v equals 0. So let's do this. When v equals 0, we have 0 equals negative 9.8 t plus 10, then 9.8 t equals 10. So t equals 10 divided by 9.8. All right. So, okay, we do 10 divided by 9.8. That is 1.02. T equals 1.02 seconds. So at 1.02 seconds is reaching the maximum velocity, the maximum height, because velocity is 0 and then goes back. Okay, so that is the time at which it reaches the maximum height. Now, what we need to do is evaluate what is the maximum height at that time. It's equal to, so now we use equation 2, 10 times the time. So this is equal to 10 times 1.02 minus 4.9 times 1.02 squared plus 20. Okay, so y at 1.02 seconds is equal to, well, this is easy. If we do 10 times 1.02, 1.02 plus 20 minus 4.9 times 1.02 squared, we get 25.1. So 25.1 meters. Okay, that is the maximum height, 25.1 meters. This is very simple. It's something that you probably did already in high school or in other classes in physics. So we have the time and we have the maximum height. Now let's see what they're asking. Time when the ball hits the ground and the velocity. All right, so the time when the ball hits the ground is very simple. We use the same equation, and now we use the distance as 0 because this is y equals 0. So when y, so this equation right here, this is a function, I mean, we can plot it. So this is already accounting for the way for the ball going up. So all we need to know is y equals 0 equals to 10 times t minus 4.9 t squared plus 20. That's equal to 0. So we have to find t. It's going to have t1 and t2. It's two roots. We'll see which one is the one we need. So this is going to be t, and this is t equal to 0. Okay, so we can already see that it has a negative root and a positive root. The negative root is 1.24, so that is not possible. It's not going to go back in time. So we have 3.28 seconds. So negative 1.2, this is not the one, is 3.2 seconds. All right, so the time when it hits the ground is 3.2 seconds. That is the time that we need to use. So when we go back to our velocity, which is this one right here, the velocity, this one right here, that equation, and we plot our time, we plug in our time, we're going to have that v at 3.2 seconds is equal to, what is the equation? 10 minus 9.8 times 3.2. So V is equal to, remember this is in seconds, so meters per second squared, and meters per second is going to give us meters per second. V at 3.2 seconds, let's fix that, is equal to 10 minus 9.8 times 3.2, negative 21.36. Negative 21.36 meters per second. Okay, So this is the velocity when it reaches the ground. So the question is, why is negative? The reason why is negative is because we have chose or y positive going up. So the magnitude of the velocity is 21.36, but the direction is opposite to our positive direction. So it's basically going down.